back to the channel. In this video, I want to talk about differentiation and the power rule. I think for a lot of people, the power rule is the first thing to know when we start off with an introduction on differentiation. And the power rule states that when we differentiate x to the nth power, we get n times x to the n minus 1. And I think how I and a lot of people would remember this is we typically think about dragging the power down and then subsequently subtracting that power by 1. And so let's do a few examples. The first example we'll do is if we differentiate x to the 7, let's say. So if we just compare this with our general formula, we can see that they're very similar in the sense that n is now substituted as 7. So if we just look at our rule over here, we're going to have 7 times x times 7 minus 1, which is 6. This also works with when the power is 1. So for instance, 24x. This now becomes 24 because we drag the power down, but remember that this is 1. So 1 times 24 is still 24 times x, and then 1 minus 1 is 0. So this is actually just 24, knowing that x to the 0 is 1. And we're not limited to integers. We can have fractional powers. So let's say we differentiate square root of x. Remember, we can rewrite this as x to the half power. And again, we can apply the same power rule over here. So this is just going to be half times x times minus half. And if we want to, again, rewrite this back to a form that might seem nicer to some people, then this is how we would do it, right? We drag the x at the bottom. And then since we've took the x and put it as a denominator, the power is now positive, so half. And further on, we can say that this is just going to be 1 over 2 root x. The power in this case can also be negative. Let's say we're going to differentiate something that looks like 1 over x squared. You don't really need to, I think it's easier if you rewrite this as x to the minus 2, because I think this makes it a lot easier for you to just, you spot the similarity between this and this very quickly. So let's keep going. This is now minus 2 times x to the minus 3. And so it's just like that. Another key point is that you can differentiate things term by term. Suppose we have the function that is f of x equals to, let's say, 3x squared plus 4x. And if we were to take the derivative of this function, which we'd commonly write that as f dash x, this is equivalent of saying f dash x is now equal to the derivative of 3x squared plus the derivative of 4x. Which, if we do it here, using the power rule as stated previously, we know that this is now 6x plus 4. And in cases where your function looks very strange, that's very complicated. Suppose we have the function that is root x to the 6 plus x minus 2 squared minus 4 all over x. We should simplify this first. That'll make, before we differentiate. So using our indices rule, we know that this is actually x to the half. And if we raise to the 6th power, this is now x cubed. Plus, I'm just going to put a bracket here by expanding this first. So this is now x squared minus 4x plus 4 minus 4 over x which is then equal to x cubed plus x squared. I'm just going to simplify this now. Minus 4x plus 4 minus 4 over x. You can cancel the 4's. Let me scroll down slightly. This is now x cubed plus x squared minus 4x over x. And of course we can cancel these x's, which is then x squared plus x minus 4. And now we've reached a point where differentiating this is easy, because if you were to take the f dash x of this is just now 2x plus 1.